Let's go through a basic problem related to magnetism. In this problem, it is specified that a coil of 300 turns and resistance 10 ohm is wound uniformly over a steel ring of mean 2 pi r or circumference 30 cm and cross-sectional area 9 cm square. It is connected to a supply of 20 volt if mu r or relative permeability of the ring is 1500. We have to find H, the magnetizing force, the reluctance, the MMF and the flux. This problem is very simple if we carefully understand the concept related to the magnetism. So basically for this problem, firstly I have to draw the magnetic circuit corresponding to this problem. Here the magnetic core is a steel ring, that is a circular cross-section ring. So I have to assume the magnetic circuit as a circular cross-section ring. This is my magnetic circuit and a coil is wound over it. It consists of around 300 turns. This is my coil. And it is connected to a supply of 20 volt. It is connected to a supply of 20 volt. Maybe alternating. It is connected to a supply of 20 volt. So since this is a magnetic circuit, we know flux will set up across the circuit as a result of the MMF N into I, and S will be the reluctance S or the opposition offered to the setting up of magnetic flux by the circuit, and H is the magnetic field intensity or magnetizing force. So this is a magnetic circuit. Here number of turns is equal to 300, and next other given parameters are, let's write the first given parameters. The number of turns N is equal to 300 and the resistance of the coil R is equal to 10 ohm. Also the circumference, here the circumference of the steel ring is given as 2 pi r is 30 centimeter. Here the circumference is the total length of our magnetic circuit. So I can represent length L is equal to 30 centimeter, and that is equal to 30 into 10 to the power minus 2 meter. And the next parameter, area of cross section, that is area of cross section of the coil, circular coil A is given by 9 centimeter square, that is equal to 9 into 10 to the power minus 4 meter square. Also other quantity given is the supply voltage V is equal to 20 volt and mu r of the circular ring, mu r of the material or steel ring is 1500. So these are all parameters given. The first quantity I have to determine is the magnetizing force. We can carefully solve this type of problems simply by understanding 3 or 4 equations. The first one is, the important one is, flux phi is equal to MMF by reluctance S. This is the first important equation. And the second one is, reluctance S is equal to L by mu 0 into mu r into A. This is the second important equation. And the third important equation, H, magnetizing force, is equal to MMF or ampere turns by length Ni by L. This is the another important equation. So simply I can solve the problem. Let's take the first part. We have H is H. We have to determine H. From the equation we know that H is equal to number of turns into current divided by length L. Here number of turns is given in the question. Length of the magnetic circuit is given in the question. But I don't know the current I which is flowing through the magnetic circuit. Instead of I, here 2 other parameters are given, that is a voltage V and the resistance of the coil. Therefore I can determine current I is equal to V by R, that is equal to 20 divided by 10, and that is equal to simply 2 amperes. Therefore 2 2 ampere is the current flowing through the coil which is wound over a steel ring. Therefore, I is equal to 2 ampere, and therefore I can determine H is equal to 300 into 2 divided by 30 into 10 to the power minus 2, and that is equal to 2000 ampere turns per meter. This is a unit of magnetizing force, a unit of mmf divided by unit of length, that is 2000 ampere turns per meter. Next is a second parameter, that is we have to determine the reluctance S of the magnetic circuit. From the equation we know that reluctance L is equal to S is equal to L by mu 0 into mu r into A. Here all the parameters are directly given and we know the value of the constant mu 0. Therefore reluctance L is equal to 30 into 10 to the power minus 2 divided by 4 pi into 10 to the power minus 7 into mu r is given as 1500. That is the relative permeability of steel ring, relative permeability of the circular steel ring. And also area of cross section is 9 into 10 to the power minus 4. Therefore, the reluctance S is given by 30 into 10 raised to minus 2 divided by 4.10 raised to minus 7 into 1590 raised to, that is approximately equal to 176.8 ampere turns per Weber. That is approximately equal to 176.8 ampere turns per Weber. And the third parameter we have to determine is the total mmf, and the total mmf is equal to Ni is equal to 300 into 2, that is equal to 600 ampere turns. 600 ampere turns. And the fourth parameter we have to determine is the flux phi. We have flux phi is equal to mmf by reluctance, that is equal to 600 divided by 176.84 into 10 to the power 3, and that is equal to 3.39 into 10 to the power minus 3 Webers into 10 to the power minus 3 Webers. This is all about solving simple magnetic circuit problem. So we have to carefully understand three different equations, that is flux phi is equal to mmf by x. It is similar to the equation of electric current is equal to emf by resistance. Here magnetic flux is equal to mmf by reluctance, and the physical parameter equation for reluctance S is equal to L by mu 0 mu r into A. L is the length of the magnetic circuit or length of the magnetic circuit. A is the area of cross section of the core. A is the area of cross section of the magnetic core. And H is equal to Ni by L is the next equation for magnetizing force or magnetic field intensity. Thank you.